Okay, we've done question 1, we've done question 2. Now I'm doing question 3. Tell me which question you want to see next. Do we just go to 4, 5, 6 up until 12, or shall we jump to one specific question that you had the problems when you were doing today in the exam? Let me know in the comments. But nevertheless, let's take a look at 3.1. Write down the radius of the third circle. Let's take a look at the information that we have. A circle with radius 6 centimeter is drawn. A second smaller circle is drawn through the center of the first circle and also touches the first circle internally as shown in the diagram. A third smaller circle is drawn through the center of the second circle and touches the second circle internally. The process of drawing circles continues and forms a geometric pattern. Okay, so that is what we have. They form a geometric pattern. Back to our equation. What does it say? Write down the radius of the third circle, and that is for 2 marks. Okay, we can do it the easy way, conceptualizing. Let's go ahead and take a look at that. So we know fully well that the radius of the biggest circle is 6, right? So we have 6 there, and we have 6 right there. So that is also 6, okay? And then let's take a look at the second smaller circle. The second smaller circle should therefore have a radius of 3, right? We're going to have 3 here, and then we're going to have 3 there. And then now let's come to the smaller circle. So the smaller circle, it has a diameter of 3. So the radius, let me just put a dot here. Oh, that is too big. So maybe this is going to work. No, also too big. So the radius of the smallest circle, that is the center, right, should be 3 over 2. That side, right? At this side, we also have 3 over 2. So that is the radius of the smallest circle is 3 over 2. So the answer to 3.1, 3 over 2. This is the answer to 3.1. How are we getting to 3 over 2? The radius of the biggest circle is 6. The radius of the circle that follows is 3. And the radius of the third circle is 3 over 2. Right, we can clearly see that we have 6. And then here we're going to have 6 as the diameter and 3 as the radius. Here we're going to have 3 as the diameter and 3 over 2 as the radius. So there we go. And then 3.2, calculate the sum of the areas of the first 10 circles. And that is for 4 marks. Calculate the sum of the areas of the first 10 circles. Well, honestly speaking, I don't think this question should be for 4 marks, right? Because I think there's a lot of dots that we need to connect in order to answer this question. So calculate the sum of the areas of the first 10 circles. So let's think about this. The sum, let's say sum of A, right? The sum of the areas is going to be pi r squared, right, for the first circle, plus pi r squared for the second circle, plus pi r squared up until some last pi r squared, okay? Because we're looking for the sum of the areas of the first 10 circles. Okay, right. So this is what we have. Obviously, the radius, the first radius is going to be of the first circle, and then the second circle, and then the third circle. So how are we going to be able to do this? Do we calculate the areas of one circle at a time up until 10? That doesn't seem very efficient, right? Take a look at this. We can say that the sum of the areas of these circles is equals to, let's take pi as a common factor. Let's take pi as a common factor. So we're going to have r1 squared plus r2 squared up until the 10th circle. So we're going to have r10 squared. So what can we do? We can use a bit of math to find the sum here. We can use a bit of math to find the sum right there. But then you need to realize something, that r squared is not r, right? So we need to take this pattern that we are seeing from the radius of the circles and form r squared as a pattern. Okay, so when we looking at the sequence that is made up of the radius squared of the circles, the first radius should be 6 squared, right? And then the second radius should be 3 squared. And then the third, therefore, should be 3 over 2 squared, so on and so on, up until the last circle. R10. Okay, so this is the sequence, so to say, that is formed by the radiuses of these circles, right? The radiuses squared, because that's what we are now interested in as we attempt to find the areas of these circles. Okay, so 6 squared, obviously, that is 36, and then 3 squared, that is 9, but no need to worry about that. We just need to realize that A, the first radius, is 6 squared, right? The first radius squared. And then R, we need to distinguish this R. This R is not the radius, but rather the ratio, right? Because we know that we have Tn is equals to AR to the power n minus 1. This R is not the radius, it's the ratio. So don't confuse it with the two, with the radius. This is actually the ratio. So the ratio is equals to T2 divided by T1. So we're going to have 3 to the power 2, 6 over 2. So this is 9 over 36. So this is A, this is the radius, and then let's find the sum, right, of the first 10 terms of this sequence, of this series, because we are talking about the sum. So to find the sum, we have Sn being equals to, well, let me take my question paper and look at the formula, right? Don't want to make any mistakes here. So the sum of some n terms in our formula sheet is given as a r to the n minus 1, everything divided by r minus 1. That's what we're given. So the sum of the first 10 terms, we're going to have a being equals to 6 to the power 2. So we have 6 to the power 2. And then we have r being 9 over 36. And then this is to the power 10. We subtract 1 and we divide everything by r minus 1. So that is 10 minus 1. So I just need to put that in my calculator. So 6 squared multiplied by, well, 6 squared, that's 36, multiplied by 9 over 36, everything to the power 10, minus 1 divided by 10 minus 1. I'm getting, let me just verify that I'm doing the right thing. So the first term is 36, okay, and then that is followed by, okay, yeah, I have r minus 1. I substituted 10 there, which is wrong, right? It's not n minus 1, but r minus 1. I was getting a negative number, so I was getting surprised. So r is 9 over 36, and then we subtract 1, okay, and then the answer is 47. So S10 is 47.99995. Okay, and then let me open the instructions on the question paper and see if I can round off to 2 decimal places. Answer all the questions, number the questions correctly. If necessary, round off to 2 decimal places unless stated otherwise. Okay, so I can round off to 2 decimal places, right? So that is S10. That is this entire thing. That is this entire thing. So the sum of the areas is going to be equals to pi multiplied by 47.99995. So this is just 47.99995 pi, of which when you round off to 2 decimal places like we can, we get 48 pi. So the sum of the areas, some units squared. Yeah, are we given the units? No. Oh yes, we're given centimeters actually. So centimeter squared. So there we go. That is the sum of the areas. I know there's somebody who got 48 but forgot to include centimeter squared. Yeah, there has to be somebody who made that mistake. But anyway, sorry, that is 3.2. Let's take a look at 3.3. So 3.3, which circle has a diameter of 3 over 128? So this is the diameter, right? Diameter is equals to 2r. We're interested in r. We've been talking about r here throughout. So let's go ahead and find r. So r is going to be 3 divided by 128, everything divided by 2. So 3 divided by 1, 2, 8, everything divided by 2. I'm getting 3 divided by 2, 5, 6. So which cycle has a radius of 3 divided by 2, 5, 6? We have to go back to this sequence that is made up of the radiuses, right? Because the first radius is 6 followed by 3 followed by 3 over 2, right? And we know fully well that Tn is equals to Arn minus 1. So Tn, we're looking for a radius which is 3 over 2, 5, 6. A is the first term, 6. R is 3 over 6, which is 1 over 2, right? Yeah. So we have 1 over 2 to the power n minus 1. So we're looking for minus 1 here. So from the get-go, we can just divide both sides by 6. So I'm getting 1 over 2 n minus 1 being equals to 1 over 512. Okay, so I can just introduce log on both sides here. I get n minus 1 log of a half being equals to log of 1 over 512. So obviously I'm gonna get n being equals to log of 512 with a base of a half when I divide by log on both sides, and plus 1 when I take 1 to the other side. So let me just substitute that in my calculator. Where is log here where I can write a base? It's running away from me, so let me just use log as it is. So I have a log of 1 divided by 512 divided by log of 1 over 2 plus 1, yes, and then I'm getting 10. N is equals to 10. So which cycle has a diameter of 3 over 128 centimeters? The 10th cycle. The 10th. Yeah, something like that. But n is equals to 10. There we go. Question 3. Which question should I do next? Let me know in the comments.